Okay, this is not the screen that you usually start out with, but we are going to start with, for number 11, we're going to start by graphing this line. So we have y equals x to the fourth, and plus 2x to the third. It's kind of fun to watch the cubic function take, and then it becomes quartic, and well, I guess it starts out quartic and changes as we go along here. Minus 12x squared, I think I got this right, plus 14x, and then finish it out with minus 5. Okay? So let me just make sure we got this right. X to the fourth plus 2x to the third minus 12x squared plus 14x minus 5. Okay, so the next thing we're going to do is just maybe make this a bit smaller so that we can see what's going on here. All right, so we need to find our intercepts, okay? So click on this. We can see our intercepts are 1 and negative 5, all right? So graph this and find the intercepts. Whoops. So we know the intercepts are 1 and negative 5, all right? Now, find the multiplicity of each root by factoring. So the fact that 1 and negative 5 are both x-intercepts means that one of the factors is x minus 1, another factor is x plus 5. Now, we don't necessarily know what the other factors are, but at least we know based on this, we can feel confident that 2 of the factors are there. So rather than doing all kinds of long, crazy division, I'm just going to use synthetic division to figure out what my other factors are. And since 1 is right here, I could use 1 or negative 5, but since 1 is right here, I'm going to go ahead and use 1. So I put my 1 here and then start filling in these values. 1, 2, negative 12, 14, and negative 5. Okay, so bring down my 1. 1 times 1 is 1. That gives me 3. By now you should be pretty fast at synthetic division. 5, negative 5. Whoops, no, that's positive 5. Okay, so here's 0, right? I had told you in another earlier video that we were gonna talk a little bit more about when the remainder is 0. Here it is. Here the remainder is 0, which means that whatever this polynomial function is right here, it's an even factor, okay? So we know this is x to the 0, so this would be x to the first, this is going to be x to the second, and this is going to be x to the third. Now, I know that right now what I have as my factors, here are my factors, x minus 1 times x to the third plus 3x squared minus 9x plus 5, okay? I know that because the remainder is 0 here, and this was my other factor. But that's not necessarily, we're not necessarily done factoring, so let's factor again. Well, I also know that x plus 5 is a factor. So x plus 5 has got to be sitting in here somewhere. So let's use synthetic division and figure out what the other factors are, okay? In other words, let's break this polynomial up a little bit more. Well, now we have 1, 3, negative 9, and 5, okay? So we're just going to use synthetic division again. 1, negative 5, negative 2, this gives me 10, that's 1. Check it out. It comes out evenly again. Well, we shouldn't be surprised because we knew we were breaking this thing up into all of its linear factors. Remember what I told you about binomial linear factors? That means these are linear. Okay, so this is x to the 0 power here. This is going to be x to the first. This is going to be x to the second. Okay, well, running out of colors here. All right, so now we know that we have x minus 1. We knew we have x plus 5. And now we can be confident that we have x squared minus 2x plus 1. Okay, you might think, well, why didn't I put my x plus 5 into here? Well, the only thing I knew for sure was, I knew both of these were factors because of this stuff up here. But when I did the synthetic division, the only thing, it was x minus 1 times all of this. So that's how I knew that there was still an x plus 5 tucked in here somewhere. which is exactly why I use x plus 5 or negative 5 as my divisor in my new synthetic division problem. So now from here, you should be able to factor by, you should be able to see that you can just factor normally. This is x plus 1, x, so that'd be x minus 1. This is a perfect square trinomial. Do you see that? So here we have x minus 1 and we have x plus 5. Okay, look at that. X minus 1, x minus 1, x minus 1. It happens 3 times. So find the multiplicity of each root. The multiplicity of 1, and we knew that 1 was going to be a root, right? We saw that on the graph, okay? So back here, we saw that 1 was going to be a factor. We saw that 5 was going to be a factor. Now we're just saying how many times. What's the multiplicity? The multiplicity of 1 is, let's do multiplicity of 1 is 3, okay? The multiplicity of 5 is 1. Actually, negative 5 is 1. What we're saying there is that x plus 5 appears once as a factor, x minus 1 appears 3 times as a factor.